So, hello everyone. So, let's start today's class. So, in the last class, up to latent heat we have finished, and now three states of matter. So, we know three states of matter, that is solid, liquid, and gaseous state. Yes. So, you see here, in case of ice and water and vapor, we can say ice to water. When we are heating it, ice will get converted into water. And when we are doing reverse process, that is when we are cooling, water will get converted into ice. So what is melting? First of all, melting is a process of changing the solid phase into liquid phase. Yes, process of changing the solid phase into liquid phase. Next, freezing, process of changing the liquid phase into solid phase. Liquid to solid means fusion, and solid to liquid means melting, as you know this. Okay. Next, vaporization, process of changing the liquid phase into the gaseous phase. Condensation, the process of changing gaseous phase into liquid phase. Gaseous state to liquid means vapor to water, like that. If anywhere it is happening, that is what? Condensation. Next, now see this graph. On y-axis I have taken temperature, on x-axis I have taken heat, and you can see A to B, this is what ice, and at 0 degrees Celsius, this BC line you can see here, it may be ice or water, but both are at 0 degrees Celsius. But from C to D, the state changes from ice to water. Yes, or the temperature of water may increase also. Again, D to E, there is water or vapor, both are at 100 degrees Celsius. And again, when we are increasing the temperature, this is what? Superheated steam, that is above the 100 degrees Celsius. So from this graph, we can say that at 0 degrees Celsius, ice as well as water can exist. And here at 100 degrees Celsius, water plus vapor also can exist. Okay. Now see here, some note point I'm going to give from this graph. This length of AB is directly proportional to latent heat of fusion. More the length, more will be the latent heat of fusion. This D, you can see, length of D is directly proportional to latent heat of vaporization. Okay. Slope of AB line, you can see here, slope of AB. So it is direct proportional to 1 by mass into specific heat of solid. And slope of CD is direct proportional to m by specific heat of liquid. So if they are giving like this graph and they are asking some question related with these note points, you can use this formulas. Okay, right? So note down fast. So let's move ahead. The next topic, that is effect of pressure on melting point. So what will be the effect of pressure on melting point? So you see, as pressure changes, as P changes means pressure changes, melting point also changes. So there is one relation, Clausius-Capelon relation. dP by dt is equal to L by T into V2 minus V1. So in this V1 and V2 is what? Volume per unit mass of solid and liquid respectively at temperature T. And this dP by dt is ratio of change of pressure with change of freezing point. And L is what? Latent heat of fusion. So what is the effect of pressure? Let's see. For example, suppose ice and iron type of substances are there. Their melting point can be lowered by increase of pressure. Okay, some substances are there. For example, ice and iron. Their melting point we can decrease by increasing pressure. Whereas you see some substances like wax and copper are also there, whose melting point can be raised by increase of pressure. Okay. Now, this question they may ask in IPE for 2 marks. What is regulation? When pressure is applied, ice melts at low temperature. If pressure is removed, water refreezes, and this refreezing is called regulation. So you take 1 rupee coin and keep it on ice, and you just press it, water will form. Again, you remove that coin, again ice will form. This is nothing but what? Regulation. So when we are cutting the ice, no, that time we are using this only. If suppose we will take one small thread and we will hang 2 weights, then slowly that thread will come down with what we can say, with the help of that we can cut the ice into 2 pieces. Got it? So note down, I will show the diagram on next page. So see in this diagram, this is what ice cube, which we have discussed before, and this is what wire, and there are 2 weight hanged. So due to this pressure only, this ice will get melted and slowly it may cut. Yes, no? This is what regulation, right? So what is the application of this regulation? You see, skating is possible on snow due to the formation of water below the skates. So what happens when you are skating? Due to the pressure, ice will get melted just below the skate, and that ice will get converted into water. So this water will behave as a lubricant, okay, and that's why there is no friction, and that's why skating is possible on snow due to what? Regulation only. Okay, right? Understand? This question they may ask you for 2 marks. Just read carefully. Next, you see boiling point, the temperature at which liquid converts into vapor. You know this. And the boiling point of liquid increases with increase in pressure and decreases with decrease in pressure. More the pressure, more the boiling point. Yes, less the pressure, decreases the boiling point, we can say. Yes, no, right? So see, in pressure cooker, the cooking occurs at 2 atmospheric pressure, and water will boil at temperature of 120 degrees Celsius. Actually, if at pressure is less, water will boil at 100 degrees Celsius only. But in pressure cooker, as pressure is more, water boils at 120 degrees Celsius, and that's why food cooks easily. Okay. Next, you see on top of the mountain, egg does not boil with decrease of pressure. Boiling point of water decreases, and that's why it is difficult, we can say, on mountain to cook food. Even we will feel that water is boiling, but still the food or egg will not cook. Okay, why? Because their pressure is less. That's why boiling point is also less. It is less than 100 degrees Celsius, and that's why it will not boil, or that's why food will not get cooked. Okay, note down. So let's move ahead. Now, next one is sublimation. What is sublimation? Process of change from a solid to the vapor state. Process of change from a solid to the vapor state. Direct from solid to vapor. For example, ice to direct steam. This process is called sublimation. Next, vapor to solid, direct from steam to ice. That is nothing but what? Permafrost. Next, sublimation occurs only if the boiling point at atmospheric pressure is less than melting point. When it is occurring, see, sometimes you will see that even you see in summer, water stones are falling. No, That is due to this only. So vapor to solid, direct hoarfrost. Okay. Next, triple point of water. Triple point of water is what? It is a point in the phase diagram which represents all three phases of water in equilibrium. All three phases in equilibrium means what? Ice, water, and vapor. All these three will be at one point at particular pressure and temperature. That is nothing but what? Triple point of water. You can see in the diagram. See here. You see this is ice line, this is steam line, this is sublimation line. In between these two lines, this region is what? Vapor. In this ice line and steam line, whatever this region is there, here it is in the liquid form. Water is in the liquid form. And in between this ice line and sublimation line, this is in solid state. So this point P is called triple point of water, and this exists at what pressure? 610.24 Pascal or 4.58 mm of Hg. And what is the temperature? 273.16 Kelvin or 0.01 degree Celsius. So at this temperature and at this pressure, triple point of water exists. And what is triple point of water means? The point where all the three states of water are in equilibrium, or we can say coexist, right? So note down and draw this diagram. This question they may ask you for 4 marks in IPE. Okay, note down. So let's move ahead. Now next one, that is heat transfer. How many modes of heat transfer are there? See, first one is conduction, and this conduction, how it takes place without movement of particles. For example, heat transfer from rod. We will take one rod, we will keep one end on fire, and then whatever the transfer of heat takes place through that rod, that is nothing but what? Conduction. Next mode of heat transfer, that is convection. And in this convection, actual movement of particles of the medium, means heat transfer takes place via actual movement of particles of the medium, via particles of the medium. For example, land or sea breezes. You see, during daytime, land will be hot, water will be cool, and that's why heat transfers from hot to cool. Okay, means that is through particles of the medium. That mode of heat transfer is called convection. Next one, you see radiation. This radiation is the mode of heat transfer which does not require any material medium. For example, sunlight. Even through vacuum also heat transfer takes place. Okay, that is what? Radiation. And always keep it in mind, it always flows from hot end to cold end. So let's see in detail one by one. So first we are going to start conduction. What is the conduction? And in the conduction we will go in deep. So let's start from temperature gradient. What is temperature gradient? See here, this is one conductor, and this Q is what? The heat flow through this conductor. Let us choose 2 points, θ1 and θ2, which are at distance x. Then what is the temperature gradient? The fall of temperature per unit distance is called temperature gradient. Means fall of temperature means θ1 is definitely greater than θ2. Why? Because heat flows from hot to cool end. So the fall of temperature per unit distance means what? θ1 minus θ2 by x is nothing but what? Temperature gradient. And that's why temperature gradient is equal to θ1 minus θ2 by x. E1, we are denoting this temperature gradient with minus d theta by dx, and minus indicates as you are increasing the distance, temperature will decrease. That's why temperature gradient we are denoting with minus d theta by dx. Okay, so note down. So let's move ahead. And now thermal conductivity. So see, I am taking one conductor whose area is A. At this end, temperature is theta1, temperature is theta2 at another end. And you can see here Q direction is this side. It means what? Theta1 is greater than theta2. And length of this conductor is L. So amount of heat flowing through this conductor is direct proportional to area of cross section. Matlab, more the area of cross section, more amount of heat will flow. Next, this amount of heat flow is direct proportional to change in temperature. More the change in temperature, more amount of heat will flow. Next one, this amount of heat is direct proportional to time. More the time, more the heat. Next one, it is inverse proportional to length. More the length, less will be the heat. Okay. And less the length, more will be the heat. Inverse proportional. Next, if we will combine this all, Q is direct proportional to A theta1 minus theta2 into T by L. And if we will remove this proportionality sign, we are going to add one constant